Bismillahirrahmanirrahim. Today we have another important topic in the organic chemistry class, that is the carbyl amine reaction. So this is also basically a test for the detection of primary amines. Let's see. So basically aliphatic and aromatic amines, they undergo this carbylamine reaction. So what we do, when an amine is warmed with chloroform and alcoholic potassium hydroxide, we observe an unpleasant pungent smell, unpleasant odor. Now that unpleasant odor is an indication of the presence of isocyanides. Now means basically isocyanides will be formed and they have this unpleasant smell, so that gives us an indication that your sample contains amine. So let's begin the reaction. So if you have an amine in your sample, you treat this with chloroform and potassium hydroxide, then gentle heat, you will get this isocyanide, and this isocyanide has this pungent smell. Okay? So let's begin the mechanism. The mechanism is that in the step number 1, this chloroform reacts with the base. Now base abstracts a proton from the chloroform, so you'll get this species, because H positive is released, so you'll get negative charge on the carbon. Now this gets transformed into a carbene by removal of the Cl negative, because you had negative here. So this is called as the dichlorocarbene. Now this is very important. So in this mechanism, the species which is formed is dichlorocarbene. And then amine is a lone pair. Now dichlorocarbene is electron deficient. So this amine is a lone pair, so it attacks here. Okay? It's a base. So what happens when amine attacks, nitrogen gets a plus charge. So you can see here nitrogen is a plus charge. Now nitrogen is a plus charge, it's highly electronegative. So what it will do, it will try to remove this plus charge. So this bond is their NH bond. So this bond moves towards nitrogen so that this plus charge gets minimized. And this hydrogen atom comes on this carbon. So you have this compound formed. Now in this case, in the next step, another chlorine molecule removes because Cl is highly electronegative. So carbon gets plus charge, which is stabilized by a lone pair here from the nitrogen. So you'll get this compound. Now in this compound, again nitrogen is the plus charge because lone pair was involved here. So nitrogen highly electronegative, one of the highly electronegative atoms, plus charge not stable. So it will get stabilized by this NH bond. So this H is removed. So now you have finally this compound. In the last step, this Cl further removes in the form of Cl negative, and then at the same way this lone pair moves towards this, between these two atoms to form N-C triple bond, but again nitrogen is a plus charge. So to stabilize this, again nitrogen is a plus charge. So and then if you see on this side, you have this CH bond, and then the hydrogen leaves with the help of this base to form water. So you will get this carbylamine. Now this carbylamine, it contains NC. This basically is it's a formula for isocyanide. So that's why carbylamine is also called as the isocyanide. It's also called as the isocyanide, depending on the R group. And in isocyanide, we know nitrogen is a plus charge and carbon is a negative charge. So it's basically N double bond C, and then we have a coordinate bond from this to this. We have a coordinate bond from this to this. So that's why we have a plus charge here and we have a negative charge here. So this is what all about the carbylamine reaction. Very, very important as per the competitive exams and any type of exams are concerned. So thank you. This is what we have.